So good afternoon. Well, today I would like us to discuss lesson 9, and this is going to be the last lesson. It's about data representation. A very new lesson to us. Data representation is about conversion from one base to another, and we just in the previous lesson discussed input-output organization. But remember, computers understand only zeros and ones, and I want to start from there. We understand 1, 0, 1 up to 9, and we say that is 10. That has evolved naturally because we have 10 fingers that we use them to count from time immemorial. That's how base 10 has evolved. But now with computers you have to learn about base 2, because computers understand base 2, and there is a reason for that. It's very simplistic. A computer is an electronic device, and electronic devices only understand two commands: absence of voltage, presence of voltage. Absence becomes 0, presence becomes 1. That's why you say computers that are started only zeros and ones. How then do we convert this data? You see that the memory of a computer, the memory locations are defined using hexadecimal. So we need to understand these number systems: decimal, octo, hexadecimal, binary. Most critical is decimal and binary. And I think you had covered this better in a unit, but I'm not going to assume that. I want to very briefly, but you need to be very keen, because I won't be doing a demonstration per se. I'll just be talking, and then I expect you to listen. There is a file here which you can download from. This file is the same one here, which is available here. It's the one that I'm displaying here. I have no intention, of course, going through this file one sentence per sentence, but I want us to have a look at this. First of all, I want us to briefly discuss about the decimal. In the decimal number format, we have 0 up to 9. Beyond that, they start repeating themselves. Have you observed that? 1, 2, 3, 4, 5, 6, 7, 8, 9. You see me, there is a 0 there. So beyond that, you start 1 and then 0. 1, 2, 3, 4, up to 9. We start repeating. When we are done with the tens, we go to the 20s. Then again 0, 1, like that. We have only 10 digits consistent with base 10 decimal. So if you add 1 to 2 in decimal, you get 3. If you add 1 to 3, you get 4. 1 to 4, you get 5. If you add 1 to 9, you have completed the number cycle in decimal. So what do? When you add 1 to 9, remember in class 1, you carry 1. You write 0, you carry 1, because you have completed the number setting, and then we call that number 10. That's how 10 is born. That's how this one is born. 0, carry 1, because you have completed the number set. Now compare that with the binary format, for instance. Binary has only 2 digits, 0 and 1. So if you add 1 plus 1, you have already exhausted the numbers. You can't go to 2. So you also write 0, carry 1. So 2 in binary is 0, carry 1. But we read it as 1, 0 to differentiate it from this 10. Are you together so far? I'm trying to introduce you to mental computation of conversions between decimal and binary to decimal. Now, if for instance, that explanation also plays out in octo. Octo has 8 numbers, 0 up to 7. So if you have 1 plus 2, you get 3 in octo. If you have 1 plus 3, you get 4 in octo. If you have 1 plus 7, you don't have 8 in octo. It's 0 up to 7. That's the final. So you will write 0 and carry 1. So 1 plus 7 in octo system is 10, in quotes, is 0, carry 1, kwa sababu umemaliza hiyo format. Now hexadecimal has 16 digits, have 16 values, with about 6 of them being letters. This is the format that is used to describe the memory locations. The last value in hexadecimal, if we may call it so, is F, representing 16. In other words, the last one is 15. There are 16 numbers, 0 to F. So in hexadecimal, if you add 1 to E, you get F. Tuko pamoja so far? If you add 1 to E in hexadecimal, which is equivalent of 1 to 14, you get F, which is equivalent to 15. If you add 1 to F, we don't have G. We don't have 16 in hexadecimal. We have 0 up to 15, which is represented by F. So instead of having 16, when you add 1 to F, you get 0 carry 1. That is in hexadecimal. With that explanation, I think we are done. This value decimal 2 base 10 is 2 in octo base 8, because base 8 has 0 up to 7, is 2 in hexadecimal has 0 up to F, and is 1 0 for simple reasons, because in binary we don't have 2, we have only 2 digits, 0 and 1. So if we have 1 plus 1, we have 0 carry 1, which becomes 10, or 1 0. 3 in decimal is 3, that's natural. In octo is 3, in hexadecimal is 3. What about in binary? 3 becomes the completion of 1 plus 1, because 3 is now, is a 1 0. 3 is the next number after 10, so to say in binary. Is like this number in decimal. Is the next number after 10. So 3 in binary is actually 1 1. If you want to convert this or this to decimal, then you take each number here and give it the value of the decimal, multiply it by 2 raised to the power of its place. So 0 times 2 to the power of 0. 0 multiplied by any number is 0. 1 times 2 to the power of 1 is 2. So you get 2, which is decimal. If you want to get the value here that is equivalent 1 1, the equivalent of that in decimal, what do? Take this value 1, multiply it by 2. I think let me see whether I can illustrate that briefly. I don't know whether I'm going to be able to delete it later. Let me just see. Yeah, I can do the typewriter thing. So you have hey, what's happening here? It can't do it. It can't do what I wanted us to do. It's taking time. Yeah, there we are. So so this one becomes, if I can be allowed to type inside here, it becomes 1 times 2. Let me use the correct symbol to represent the power. Where is it on the keyboard? To the power of 1 plus 1 times 2 to the power of 0. In mathematics, we know any number raised to power 0 is 1. So 1 times 2 to the power of 0, 2 to the power of 0 is 1, 1 times 1 is 1, plus, that is this one now, plus 1, the second one here, its place is that of 1, the power of 0, 1, like that. You come from 1s to 10s and so on. So 1 times 2 to the power of 1, any number raised to 1 raised to the power of 1 is itself. So that becomes 2. 1 times 2 is basically 2. So 2 plus 1 gives us 3. That technique is the one we follow even when we come to numbers like this. We can pick a number like this one. Which now becomes 1, you got to get 0 to the power of times 2 to the power of 0, 1 times 2 to the power of 1, 1 times 2 to the power of 2, and therefore 2 to the power of 2 is 4, 1 times 2 to the power of 1 is 2, 4 plus 2 is 6. But this is how it works. 1 times 2 to the power of, the last power here is 0, 1, 2 to the power of 2, plus 1 times 2 to the power of 0, 1 to the power of 1, plus plus 0 times 2 to the power of 0. Any number raised to the power of 0 is 1. So, but any number multiplied by 0 is 0. Nothing multiplied by nothing is nothing. I mean, nothing multiplied by anything is nothing. That's the power of nothing. So, any number raised to power 1 is itself. So, 1 times 2 to power 1 becomes 1 times 2. That gives us 2 now. So, here we have 2. Here we have 4 times 1, which now becomes 4. And here we have 0. So, here we have plus. Here we have plus. That gives us 4 plus 2 plus 0 gives us 6. And that's the 6 we have here. Now, supposing now we wanted to convert this into binary. 2 into binary. How do we do that? How do we do that? This is how we do it. Just in case you're wondering where that class has gone, let me help you out. Hey, come on. Alright. Now, if you want to get the binary form of this, we're going to get, by the way, that applies also, by the way, this technique also applies. If you're working with base 10 and you want to know what is 10 base 10, you get 0. Just what is 10 base 10? That's an interesting question. It is 1 times 10. No, base 2 is 2 here. Sorry, base 2 is 2 here. This is base 10, 10 here. Times 10 to the power of 1 plus 1, 0 times 10 to the power of 0. I want to show you the logic. There is no conversion you are doing here, but we want to test this mathematics. What is 10 base 10? How do you get it? So this becomes, any number raised to power 0 is 1. So this is 1 times 0, which becomes 0, plus 10 to the power of 1 is 10 times 1, that gives us 10. 10 plus 0 is 10. I mean, now you appreciate. Now we come to this. How do we now convert this to binary? Here we are multiplying. Now if we want to convert to binary, we divide. If we want to know what is 10 in binary, which becomes 10, 10, we divide by 2 continuously. Here we multiply by 10, we divide by 2. So we take the 10, divide by 2, and we get what? 10 divided by 2 is 5. Remainder 0. That is integer division. Reminds me of class 2 mathematics. Interesting. Then we have, next we take 5. We divide 5 by 2. 5 is a quotient. 5 divided by 2 is what? Is 2, because 2 goes into 5 2 times, makes 4, remainder 1. Next, we take 2 and divide by 2. 2 goes into 2 once, remainder 0. It's integer division until we have 0 here. So 1 divided by 2 goes in, if you divide 1 by 2, 2 goes into 1 0 times. If you're not doing integer division, you start putting points, but here we're doing integer division, so remainder 1. Then you pick these numbers here and read them from here upwards. What does it make? So we read them from here upwards. Help me out. It's 1 0 1 0. Is that the same number as this one? 10. That's it. Yeah, there you are. You have known how to do those conversions. That very same technique is the same technique you're going to use when you're doing the conversion to these ones. If you want to convert this 6 in octo, or let's say this 12 in octo, into binary, you follow the same procedure. You pick this 12 is in base 10, and let me see, here is almost getting confusing also. You can't divide it by 2. If we wanted, for instance, to get this 12, we get 2 multiplied by 8, 2 multiplied by 8 to the power of 0. So here we would have, for if we wanted to get this 12, we would have 1 to the power of 8 to the no, times 8 to the power of 1 plus 2 times 8 to the power of 0. Now, what does that become? Someone help us. Now, this one becomes 8 to the power of 0 is 1. 1 times 2 is 2. Plus 8 to the power of 1 is 8. Times 1 is 8. Looks like I have a problem here. 0 1, any number raised to power, yeah, this doesn't make sense. I need to revisit my maths also. Oh, my octo system is defying my formula. Let's go over that again. 8 plus 2 becomes 10. We are moving it to decimal. Let me see. Well, I need to go back to school here also. Let's see. So far the concepts had worked so far up to there. We are now trying to see how we can convert octo to binary actually, and also how we can prove that octo also holds. It holds to this. So how does 12 become? Okay, yes, it makes sense. I made a mistake. So here it is. So it makes sense. We have 1 times 8 to the power of, what am I? Yeah, 8 to the power of 1 plus 2 times 8 to the power of 0. This is what we have. Let me try to reduce that. Oh my, it can't work. Hope you understand. So these ones you can combine them just to ensure they're not hidden. I told you I don't want to go into the notes. So 8 to the power of 0 is 1, so this one becomes 2 because any number multiplied by 1 is itself. Here then we have 8 to the power of 1 is 8 times 1 is 8, but Hexadecimal doesn't have 8. What is 8 in hexadecimal? Is 1. No, sorry, in octo. What is 8 in octo? We have 8 digits in octo, 0 to 7. So if you have 1 plus 7, it doesn't become 8, it becomes 0 color 1. So our 8 here is not going to be 8, it's going to be 0 color 1. So we add these two. That's the concept I have forgotten. What do you get? 12. It's 12 we are talking about here. If you want to get this value, the value of binary, if you want to convert octo to binary, then you follow the same techniques like we followed here. And it should work, why not? So this is how we do the conversions here, and I hope you have understood the concepts. As long as you remember, this one has a maximum of 8 digits, this one has a maximum of 16 digits, 0 up to 15, 0 up to 7, 0 up to 9, 0 up to 1. Then you can do the conversion with a lot of ease. I wish you will try it out. Actually, the rest of the document is just about that. I don't want to dwell so much on it. Look at that. It's just the conversions here. Being taught how to go about them. Number conversions. What I'm talking about here. The powers. You know that too. Converting that to decimal. You know this number. Converting it to decimal. How it's done. Power 1, 2, 3. It's supposed to be start from power 0, 1, 2. So some mistake there of some sort. So I think you're well with the explanation I've given you here, and I think it suffices. For that reason, I wish you well. Thank you. That's the end of our lesson. Now the thing I'm going to do going forward is that I'll give you a quiz, the second quiz, and also a card. The second quiz is going to be immediately after lesson 9. No, I think we should rather put it earlier. Immediately after lesson, so that you have lesson 6 and lesson 7, lesson 8 covered. I'm going to see, but you're going to have a quiz and you're going to have card 2. So that quiz 1, quiz 2, and then card 2, that will suffice. Please, this card, you're going to follow the instruction, but I'm hoping you can be able to submit it by Thursday next week, so that you'll have learned all that you have learned here. Thank you. Enjoy yourselves. Have a nice afternoon.